Hello guys, today we're going to finish 1.3, which is pretty much interquartile ranges and box plots and how to mathematically determine if something is an outlier. No more needing to just look at it and guesswork. I hate guesswork. Now we can mathematically calculate an outlier. So first of all, let's go over the definition the book gives of quartiles. Pretty much quartiles of a distribution divide the ordered data set into 4 groups having roughly the same number of values. 4 groups. That's why it's quartiles, like a quarter. Divides it into 4 groups having more or less the same number of measurements. How do we do this? Simple. We find the median of the population. And then on the first half, we find the median again. And on the second half, we find the medians. So you have to do 3 median operations to find the quartiles. Roughly the same amount of measurements should fall into these groups. Now note, this is the first quartile, this is the second quartile, and this is the third quartile. The second quartile can also be called median, that's fine. But note, there are 3 quartiles, but 4 groups. So we divide the population into 4 quarters by using 3 quartiles. So again, you find any measurement and you find the median of the first one. You find the median of the original population. Let's say it falls right here with about half and half of all the measurements. Then we find the median of the first half, divide them by 2 groups, and then the median of the second half divided by 2 groups. Note that each group has 3 measurements, and again, this line represents the first quartile, this is the second quartile or median, this is the third quartile. Now, IQR or interquartile range is used when we want to focus on the middle values. We don't care so much about the extremes or the outsides. So many times people just focus on the inner quartiles between the first and the third. These would be, the outside groups. So many people focus on these 2. Now, in order to find the inner quartile range, or the interquartile range, the interquartile range is the range between the third quartile and the first quartile. So let's say this is 26, and this is, again, this is slightly less than 26. This is slightly more than 20. Let's just say it's 26 and 20. The interquartile range would be 6. And you'll see pretty much why that's important now. Okay. Now, why do I need the interquartile range? We need the interquartile range because that's how we find outliers. Once you calculate your interquartile range, which in this case is 6, you're going to multiply that number by 1.5. Now note, in med school I've seen books that, change this number depending on how strict you want to be on whether something is an outlier or is included in your measurements. So there is some flexibility there, but for exam and AP stats purposes, that number is always going to be 1.5. But it can change in real life. But for now, 1.5. So when you multiply your interquartile ranges by 1.5, it's going to give you a number. That number is added to this value and subtracted to this value. So if this value was 26 and I add 9, I end up with 35. If this value was 20 and I subtract 9, I end up with 11. Anything above 35 can be considered an outlier. Anything below 11 can be considered an outlier. And note that it is not equal to these values. It is greater than these values. So a value of 35 is just an extremely high value, but it's not considered an outlier. Any value above this is an outlier. Any value below 11 is an outlier. So again, to go over this process quickly, we find the median, we take the median of the first half, the median of the second half. That gives us our first and our third quartile. we subtract our third quartile, or we actually subtract our first quartile from our third quartile, we end up with a number. We multiply that number by 1.5, it gives us a new value. That new value is added to the third quartile and subtracted to our first quartile to give us some boundaries. Anything above this boundary on the right hand side is an outlier. Anything below this boundary on the left hand side is an outlier. I hope that's clear. Now we're gonna talk about the 5-number summary and box plots. Pretty much the 5-number summary and box plots are pretty much a distribution of data that displays the data that you're seeing by quartiles pretty much. You're actually gonna see quarters of data, and you'll see how that works. Now I'm gonna go ahead and erase this. Again, my markers just flying off the shelves today. Business as usual. So let's say I want to give a 5-number summary from this data I'm seeing before I give the box plot. What you're gonna do is you're gonna give the minimum measured value, 19. Let's see if I can find another marker that actually works a little bit better. 19. You're gonna give your first quartile, let's say it's 20.5. You're gonna give your median or second quartile, let's say it's 23.3. You're gonna give your third quartile, let's say it's 25.8. And you're gonna give your maximum value. Let's say that would be 27. Again, that is why it's called the 5-number summary. It gives you your minimum value, your maximum value, and your quartiles. So you know more or less where the data is concentrated in. So let's say, for example, I switch, even though now it might be a little difficult to visualize, the box plot will help because the box plot is a visualization of the 5-number summary. Let's say I have these following values. The minimum is 0. The first quartile range is 0.5. The median is 1. The third quartile is 1.5. And the maximum value is 4. I can see that there is a skew to the right because 75% of the values are here, and then the final 25 is distributed within a very large margin. And again, it's difficult to visualize this via numbers, but we're gonna build the box plot and this will help you out. So how do we build a box plot and how do we understand box plots? Pretty much what you do is you find your 3 quartiles. Your first quartile, wherever it may be. Your second quartile, wherever it may be. Your third quartile, wherever it may be. Your minimum and your maximum. Again, these are the 5 numbers used in the 5-number summary. In the box plot, it's again the visual representation of these values. So the way we do is with the inner quarters, the second quarter and the third quarter, or we're pretty much going to do a box plot with the 3 quartiles, and then we're going to draw what's called a whisker from the third quartile to the maximum and from the first quartile to the minimum, and that is a box plot. Now note, if I give you a box plot like this, you can see that the values are more or less evenly distributed throughout all these values. However, let's look at some visual box plots. Let's say I am given this box plot. What can you say there? Well, I have a huge cluster of values within these 2 ranges, because again, that's 50. Even though these are smaller than these, each part represents 25% of all measurements, not values, but actual measurements. So half of all my measurements are here, and then 25% here and 25% here. So I should have something that looks like this, because again, I have a huge concentration of measurements here. Now, if I were to change one of these whiskers, let's say, for example, instead of having it here, now I would have my whisker be like this. this would be a negative or left skew, because I would have 75% of all my values here, and then 25% distributed throughout this first group, pretty much. Now, again, that's all you need to know for 1.3 after standard deviation. How to find the quartiles, first quartile, third quartile, how to find the interquartile range, how to determine if there are mathematical outliers, how to do the 5-number summary, and the box plot. Now, note one thing. Before we do the box plot, and I have all my measurements, we are only going to include measurements that are not outliers in box plots. So again, you're going to have your maximum, your minimum, let's say your first, second, and third quartile, your whiskers. If you have any outliers outside this maximum or this minimum, you're going to draw them as an asterisk. That denotes that they are outliers and not taken into account when drawing the bar graph or the 5-number summary. That's pretty much it for today. Pretty simple. Make sure you review the book, because there are different ways box plots can be displayed, and since you know I draw incredibly well, I do not want to damage your eyes by having you see more of my box plots. So just look at the book and let's discuss questions in class. Take care, guys.